you have trained 5 versions of your machine learning model, but you can't remember the parameter. The accuracy is worse than the last time, but you don't know why. That was me actually until I found MLflow. In this video, I will show you what MLflow is and why it matters, and how to use it with a live example in fact. MLflow exists to solve a critical problem in machine learning, that is managing the chaos of experimentation, reproducibility, and deployment. Before MLflow, the machine learning process was frustrating, difficult to track what code, data, and parameters led to a result. There was no center place to log or compare experiments. We had to do manual model packaging, and that was very error prone and inconsistent. And the last thing, that was moving from notebook to production. It was nightmare for every machine learning practitioner. So here is what MLflow solves. The first and very important, that is tracking. So it lets you track, log every run, parameters, metrics, artifacts, models, and compare experiments in a clean web UI. The next is projects. You can package your code in a reproducible format and run it anywhere with just one command. And then models. It standardizes how models are saved so you can deploy them easily or load them back into Python. And the final is model registry. It gives you version control and stage transitions, like from staging to production. So you can manage your model's life cycle as a team. To set it up in your laptop, you just have to run pip install MLflow, and that's it. You have successfully installed MLflow on your laptop. To open the MLflow UI locally in your browser, you just need to run this particular command, MLflow UI, and boom, it will be empty at first, but that's where your experiments run will appear. Let's see a real example. So you can see I have already written a main.py file, which basically train and log all the details related to a linear regression model. And I have used California housing dataset, which is publicly available. You can go to scikit-learn official documentation and you can find it there. As you can see, I have used MLflow in that, and along with that I have used pandas and scikit-learn libraries. So first I will create a requirement.txt, and requirement.txt will have all those required libraries. So I have created requirement.txt and I have created main.py. Now I will open a terminal and I will write pip install -r requirements.txt. As you can see, I have already installed all the required libraries, so it is showing requirement already satisfied. If you are doing it for first time, then it will take some time and install it properly. Now once you have installed the basically all the required libraries, you can run MLflow UI, and as soon as you run MLflow UI command, this will ask you to open this particular localhost URL. So you can click on this particular URL and this will open the MLflow UI in the browser. And now you can see, like, I have already run some experiments, but I will show you how I have done this earlier. So I will again open another terminal, and you can see I have activated my environment. So you can also activate the environment before running your Python file. So I will just write Python main.py and it will run. But before that, I will explain you the code which I have written. As you can see here, I have basically imported all the necessary libraries, and then uh, I have written a main function, and the main function is being called from here. So now I will explain the main function only. So I have initialized two variables, name, test size, random state. Currently test size is 0.3 and random state is 42. Then I have loaded the California house dataset, and then I have basically fetched the independent variables and dependent variables, which is basically my input features and target features. So those things I have done. I have done train test split, and the train test split is done based on these two variables, test size and random state. So I have taken those as input here, and I have simply called a linear regression model, and then I have fitted the model using x model.fit x train y train, and then I have basically calculated some metric, that is R2, MSE and MAE, and after that the real MLflow work starts here. So I have set the tracking URL as this much. This you might be knowing what is this. It is the same URL which have taken me to the browser. So we have to set the tracking URL before we are basically starting the experiment, and then we will have to set up the experiment. So I have set up the experiment name as California housing experiment, and the next is we have to give a input example so that we can log it into our MLflow run experiments. Now as we do this, we will start run and we will log everything which we have. So we will log the model type, that is a linear regression model, then test size, that is test size we have taken on the above, the same random state, then scikit-learn version as well as R2 score, MSE, ME, all those metric. We will log everything. We have written signature here. We have taken input example, and then we have logged those things into the model. Now when I have written this much basically line of code, so what this will do, this will log everything over here in this particular MLflow UI dashboard. So as you can see, the last one which was created under California housing experiment, it was 3 hours ago. As soon as I run this particular code, so I will run this code by Python main.py. So I have already written Python main.py and I will hit enter. As you can see, the code is running and it is showing like view experiment at this much. So I will go to browser and I will refresh it. As you can see, 13 seconds ago, one more run has been added under the California housing experiment. So this is here. Again quickly I will change some of the parameters here. I will do this 0.4. Usually this is not 0.4, but for learning purpose I will change it to 0.4, and I will change this random state as well. So I will do random state 17, and then again I will run the model. So I will just do Control S, and then I will run Python main.py, and you can see successfully run, and will go to this particular and just refresh it. You can see we just 7 seconds ago one more basically run has been added, and quickly I will do one more run, and we'll see then what is there in the MLflow UI dashboard. See, I have not, focusing on what is the best model here as of now. So I will just quickly, give anything which is coming in my mind. So I will just change it to 27, and you can see there should be some different results this time as well. So I will again quickly run this MLflow, sorry, this Python main.py. Now this has been also successfully run. So I will just go to this particular California house experiment, and again refresh it. So you can see there are three runs which is basically uh, added recently, 3 minutes ago, 2 minutes ago, 11 seconds ago. So this is which I just ran, and earlier two run was there. So I will add them as well, and then I will compare. So there is one thing which is like compare button. I will go to compare, and you can see here. So first I will show you how this R2 score is basically changing with respect to the random state. So when random state was 17, then R2 was highest, and when random state was 42, then my R2 was very less, and again when random state was 27, here you can see, so the R2 was I guess 0.59. Now we can again add this test size as well. So now you can see when the random state was 27 and test size was 0.3, then our R2 score was 0.59 something, and when random state was 42 and the test size was same, that is 0.3, then our R2 score was higher, that was 0.95, almost 0.596. So that was a bit higher compared to the previous one, that is 0.591 something. And similarly, random state was 17 and test size was 0.4, then the R2 was highest, that is 0.607, and it was minimum when random state was 42 and test size was 0.2, then the R2 was minimum, that is 0.575. So this way you can basically look into the different plots. We have scatter plot as well. So in scatter plot, the same values are there, but you can visualize the things in a different way. So right now it is linear regression, so everything is under linear regression only, so that's why it is coming in the straight line. But when I change to its random state, then you can see I had taken random state 42 at 2 times. So there are two experiments, there are two R2 score over there. Similarly, you can go through the different metrics and explore the things. You can basically see the box plot as well. There are plenty of the things you can look into, and I will not explain everything because it will be related to something else, but you get the idea, right? What you have to do and how you can basically look into the different graphs, and as well as you can compare the different run you have done in your experiments. So this is for the visualization, and then I can say apart from runs you have evaluation, traces, etc. But the most important one is when you come to runs, and if you click on any run name, you will come to this screen and you will see the overview of your experiment. So you have basically created by Uday, that is my name. then experiment ID, you have status, you have run ID, you have duration. You can also log the data set you have used. You can add some tags. I mean, here you can see what was the file name which you run over this for this particular run experiment. And then I mean, as I have done, I have registered this model. So it is showing California house linear model version 5. So you can compare all your different versions as well. And the version 5 is basically having test size value zero point 0.3, random stage 27, model type linear regression, scikit-learn version 1.6.1. And in the metric you have MAE, MSE, R2 score. This is basically what you get in the overview. Then you have model metric, MAE, MSE, R2 score. These are basically in graphical format, nothing else. Then you have some system metrics. I mean, currently it is empty. I will show you all these things in the later videos. Then you have artifacts as well. So in the artifacts, I mean, you get the whole package of your machine learning model which you have trained. Then you have the basically ML model. Then you have the Conda YAML. Then you have input example which we have taken in the code. So this is basically the input example. So that is there. Then we have a pickle file of that particular model which has been trained. We can simply copy from this particular path and put it into our any project, and we can simply load this model and use it there. Then we have Python environment YAML file. Then we have requirements.txt. Then we have input example.json. So everything is there. So all the runs you will be getting here, and you will be getting the different version, like different version 5, version 4, version 3, version 2, version 1. So everything you will be getting in the model registry and MLflow UI. I think I have explained much about it. So with just a few lines of code, MLflow gives you full visibility into your ML workflow. Let's recap the real world benefits. First, team collaborate better. The second, you avoid duplication and errors. Third, reproducibility become effortless, and it speed up the model to deployment pipeline. You can also track and compare runs, avoid confusion in hyperparameters, store trained models, and scale to production when you are ready. In future videos, we will explore model serving and using MLflow in the cloud. If this video helped you, hit the like button and subscribe for more AI tools like this. Have questions? Drop them in the comments. I will read them. See you in the next one. This is AI with Uday signing off.